Good day to everyone who's watching. In our lesson today, we are going to talk about surds. A surd is an unresolved root or sum of roots, or it is a radical of an irrational number. An irrational number is that number that cannot be expressed as a ratio of two numbers. For example, root of 2, root of 3, root of 5, root of 17, root of 19, and so many others. So our rules, we have the first one there up to the third one. We are going to do examples when we are using these rules here. The first is that when we are having root of c, a root of c plus or minus a b root c, that this one is equal to, you either add the a to b or subtract a to b, then times the root c. So the plus or minus, it depends. If it is addition, you'll be adding, and if it is only the minus there, you will be subtracting. Then the second one there is all about multiplication. We multiply those under the roots, and also we multiply those outside the square root there. Then finally, the third one, root of a all over root of b. From the laws of indices, we shall get to square root of a divided by b. Example 1, simplify the following. Now this Roman one, just like in ordinary level, we are going to identify a square number embedded in 8, then we get its square root, and then that is the simplification of that one there. So the 4 is embedded in 8 together with the 2. Then now the root of 4 times root of 2, and root of 4 is a 2, root 2, to simplify the root of 8 there. Even in Roman 2, we are going to identify the square number there. That is the 16. So 16 times 3 is the one that gives us 48. So root of 16 times 3. Then root of 16 is a 4. And I have 4 root 3, just like that. For Roman 3, 125, there is a square number of 25 there. Then the root is going to cancel with the square there on y. So I'll be having 25 times 5, then times y squared. Then finally I have 5y root of 5. Roman 4 takes us to the addition combined with the subtraction there, but those figures inside the square root, we need to identify the square numbers there, and we go on to first simplify them, then we add and subtract accordingly. Now the 50 is 2 times 25. 25 is a square number. The 72, 2 times 36. 36 is a square number. The 18, 2 times 9. 9 is a square number. The 32, that is 16 times 2. 16 is a square number. So it is the 2 that's going to remain in the root Now this one gives me 5 root 2, then plus the 6 here is going to multiply the 4 to have 24 root 2, plus the 3 here is going to multiply the 2 to have 6 root 2, then minus, this is a 4 root 2 there. Now I have the coefficients of root 2 there. They are the ones that I'm going to add. So this is 5 plus 24 plus 6 minus 4 into the root 2 there. Using the first rule of Surd that I wrote, finally I get 31 root of a 2. Roman 5 is all about the expansion. You know that in the expansion we shall have multiplication there. So in O level we used to say that the root of 3 multiplies the whole of that bracket there. So this is root 3 into root 3 minus 7, then plus also the 7 multiplies that bracket there. So now I'm going to use the second law of Surds that I wrote. Root 3 times root 3, that's going to be root 9, then minus 7 root 3, then plus 7 root 3, then 7 times 7 is minus 49. This one here, I get a 3. These two are the same but having opposite signs, so they become a 0. Then I'm left with a minus 49. Then finally I get the answer as a negative 46. Roman 6 is the same as Roman 5. We are going to expand those two brackets there. The 1 multiplies the whole of that, root of 2 plus root of 5. Then the minus root 5 there also multiplies root of 2 plus root of 5. So 1 times anything is that anything. So this becomes root 5 plus root 2. Then minus root 5 times root 2, that gives me negative root 10. Then minus root 5 gives me negative root 25. So the root 25 is going to give us 5. Then this one becomes root of 2 plus root of 5 minus root of 10, then minus 5 there. So if we have the compound surds, for example this one here, this denominator, its conjugate is the other one there. If the sign is minus, then the conjugate must be having an addition sign there, and if it is an addition sign, then its conjugate must be having a negative. So this is how we rationalize the denominator of an irrational number. If it is just a single fraction, for example root of a divided by root of b, so I just come here in the numerator, I multiply the root of b in the denominator, then I also multiply it in the numerator there. Example 2, express the following with rational denominators. So I'm going to get the conjugate of 1 minus root 3, then I multiply both in the denominator and the numerator. So now I'm going to expand in the numerator the 2 into 1 plus root of 3, then plus root of 3 into 1 plus root of 3. Then divide by, in the denominator, I'm going to apply the idea of difference of two squares. If I have a plus b into a minus b, that this one gives me a squared minus b squared. So this one is what I have here, where my 1 is the a and my b is the root of 3. Now I'm going to be writing 1 squared, then minus root of 3 squared. When I expand here, this I'm having 2 plus 2 root 3, then plus root 3, then this is plus root of 9. So this is a 1, then minus a 3, the square cancels with the square root there. Then now, when I simplify in the numerator, this is going to be 2 plus the root 3 has a 1 there. Then I'm going to add it to this. So this is 2 plus 1 into root 3. Then the root of 9 is 3. Divide by the denominator, I'm having a negative 2 there. So the 2 adding to 3, I have a 5. Then here I'm having plus 3 root of 3 divided by negative 2. Now the negative 2 divides 5. I have negative 5 all over 2, then minus 3 all over 2 root 3. As simple as that. This Roman 2 it has two alternatives. We can either first get the LCM here, then later on we rationalize the denominator, or we first rationalize that particular denominator and also rationalize that one there. So the two alternatives, this is what I was talking about. First rationalize that part there and also rationalize that one, or you can get the LCM of the denominators, then you keep on simplifying, open the brackets in the denominator, then you rationalize after. So me, I'm going to choose this one. Then you can try out that one and see if we are going to get the same answer. So this part here, this we have 3 plus root of 2, then divide by 3 squared minus root of 2 squared, then plus 3 minus root of 7, then divide by 3 squared minus root of 7 squared. In the denominator, I'll be having a 9 minus a 2. Here in the denominator, I'm having 9, then minus a 7. So when I subtract here, I'm having a 7. And when I subtract here, I'm having a 2. Now, both of my denominators there, they are rational numbers. So now I can get the LCM. So the LCM is a 14 there. Then here I come back and multiply there a 14, and even there times a 14. So the 7 reduces that to a 2 into 3 plus root of 2. Then this one is a plus 7 into 3 minus root of 7. Opening brackets, this is 6 plus 2 root 2, then plus 21 minus 7 root 7, then divide by a 14. Now I can add these figures here, 6 and 21, to have 27 plus 2 root 2 minus 7 root 7. Then divide by the 14. So I have expressed this whole expression with a denominator which is rational. Example 3. Find the square root of 6 plus 2 root 5. So here I'm going to let my square root of 6 plus 2 root 5 to be equal to root of x1 plus root of x2 there. Now I'm going to find a way of getting the x1 and the x2 there, and that one is going to be my square root. So using the concepts of algebra, now I'm going to square both sides. I square this side is equal to root of x1 plus root of x2, and also this one here is squared. Now on the left hand side I'm having 6 plus 2 root of 5 because the square cancels out with the square root. Then on the right hand side I'm going to use the identity of a plus b squared, that on expansion this one becomes a squared plus 2ab then plus b squared, where my a is the root of x1 and my b is the root of x2 there. So when I use that identity, I'm having root of x1 squared then plus 2 root of x1 then times root of x2 then plus root of x2 squared. On the right hand side, simplifying, here I'm having x1 then plus the other one is x2 then plus the 2 root of x1 times x2. So at this stage here I'm going to compare the constant terms and also the terms that have the square root. So x1 plus x2 they are going to be equivalent to 6. And also 2 root 5 is going to be equivalent to 2 root of x1 times x2. So I'm going to form two equations there. So the 2 here is going to cancel, then also squaring both sides, I'll be having the x1 times x2 to be equal to the 5 there. I come back to this, I make x1 the subject, so my x1 is going to be equal to 6 minus x2. Then I get this, I feed it into that equation there. Because of space, I had to first rub the other work. Then these are the two equations that we had there. Then forming the third equation, then I substitute here. Now I'm going to be having 6 minus x2 into x2, and this one is equivalent to a 5. When I open the bracket, I'll be having 6x2 minus x2 squared is equaling to a 5. This is a quadratic equation. In O level, we looked at solving quadratic equations, that you take everything on one side, or you make one side to have a 0. That is, if I take these ones, the other side, this is going to be x2 squared, then minus 6x2, then plus 5 is equal to a 0. Now you look for the factors there, and then you factorize, and then you get the values of x2. So the factors, we have negative x2 and negative 5x2, then plus 5 is equal to a 0. Then factorizing there, we have x2 into x2 minus 1, then even here minus 5 is common, into x2, then minus 1 is equal to a 0. Factorizing further, I have x2 minus 5 into x2 minus 1, and this one here is equal to a 0. Then I begin either one bracket is equal to 0 to have x2 as positive 5, and another bracket is also equal to 0 to have x2 as a positive 1. Now I go back to equation 3 there to get the corresponding values of x1. So using equation 3, x1, when I put the 5 here, I'm having a 1. Then when I put a 1 there, I'm having also a 5. The square root of 6 plus 2 root 5 is equal to plus or minus 1 plus root of 5. So now I cannot put 5 plus root of 1, because root of 1 is just a 1. That is why I put the 5 under the square root and the 1 right there.